Google Developer Student Clubs train hundreds of thousands of university student developers globally while having fun getting to know other students at their school. Google selects students with strong leadership skills from across the globe once a year to start a club on their campus. These leads believe knowledge is power and that technology can do extraordinary things for the world. They take on the responsibility to help students learn and empower each other to solve real problems around them. Students can participate in the annual Solution Challenge by Google developers to solve for one of the United Nations Sustainable Development Goals. Join us in building a global community for students in technology.
Hello, everybody. My name is Trevor. I'm part of the Google Developer Student Club at ETH Zurich. Thank you for joining us today. Today we have a guest speaker from the Web3 Foundation who's going to give an introduction about blockchain technology, Web3, and all that cool stuff. So his name is Emre. His background is in full stack software development, education, and blockchain technology. He's very passionate about learning and teaching. And yeah, he works as a technical educator at the Web3 Foundation in Switzerland. So with that, I will let Emre take it away from here.
Thank you, Trevor. Welcome, everybody. My name is Emre. As Trevor mentioned, I work at the Web3 Foundation. I'm super excited to talk to you guys today about blockchain, Web3, and how Polkadot fits into those topics. Just want to get a quick maybe feel for how everybody feels about blockchain technology. So if you'd like to, in the comments, drop a number between 1 and 5, 1 being absolute beginner, 5 being somewhat of an expert in the technology of blockchains, how you feel about it. So drop us a comment. And then just want to get a heartbeat on the crowd as I get started. This is a beginner's, somewhat of a high-level overview of blockchain, Web3, and Polkadot. What I'll start off with is a question, and what is Web3? What do we mean by Web 3.0? You know, the foundation is called Web3. We have Web 3 that's just a single word, or Web 3.0 as kind of like this 2 separate words. What is it? So in my view, the Web 3.0 is still being defined, right? So we're trying to land somewhere in the next evolution of the web. Where is it going? What type of technologies are running it? What are the protocols? What are the types of interactions that it allows for people that participate on it? And so at the Web3 Foundation, we have kind of our own philosophy we'll talk about. But before that, I think it makes sense to kind of take a look at how we got here, right? So the internet, as we know it, spans back to the 70s. Even slightly before the 70s when the first protocols were being developed. But we can kind of think of 1970 to 1990 as this kind of era of the internet where the network was being developed. So the networking protocols were being developed. Things like ARPANET, IP, TCP, UDP, these types of like communication protocols that allowed the interconnectedness to work, right? So if you think about the early days of the internet, they were just being isolated nodes running in universities, research labs, the army, private companies, and they were not able to really interoperate until things like IP that allowed the location of those nodes to be given to each other, and TCP, kind of like this protocol that allows for chopping up of data into packets and passing it back and forth in a uniform protocol that all these nodes shared. Then data was being kind of shared across this network. right? And then we get into the 90s, where we saw the personal computer. We saw hypertext transfer protocol, so HTTP, which was built on top of those networking developments decades before the 90s, that allowed for static websites to be able to communicate data between each other. So static websites, as we know, kind of were these read-only websites where you could have games or gambling and other things. So it allowed for people to start interacting with each other over their personal computers on this thing called the internet. And then in the 2000s, post-dot-com bubble, we got our smartphones, we got our social networks, we got our kind of tech giants that arose from the ashes of the dot-com bubble burst, that had some products that were in a way centralized around those entities. And in 2008, we had the mortgage securities problem and the financial recession. And in 2008, it wasn't very, I think, coincidental that Bitcoin came out. So the Bitcoin white paper, shortly after the financial crisis comes out, trying to be this peer-to-peer decentralized cash system, right? And in the decade that followed that, we started to have an evolution in the web space, which was kind of like cloud, big data, AI, machine learning. But also we had these decentralized networks that were flourishing from where Bitcoin came from, kind of this decentralization of finance that Bitcoin fostered, led to a lot of new ideas, like what else can we have on this blockchain thing? So where does Web3 kind of fit into this? This is kind of like a generalized, somewhat of a simplification as well, of where kind of the Web 1, 2, 3 kind of lie. And so this is kind of malleable. You can think of this as like a good starting point, though. So the networking development days kind of was this Web 0, 90s were this Web 1.0, 2000s were this Web 2.0, and then 2010 to now is kind of like we're in the middle of Web 2.x, let's say, and the process of defining what Web 3.0 will be. So what does that really mean? Is that what is the difference? So a simple way to look at this is that Web 1.0 was read-only, right? So these static websites, you could read them, you could load them, you could share your ideas, blogs, newsletters, magazines, whatnot, right? So just read-only. Web 2.0 took that further and allowed for applications that were, where you could write your own data to it. You could update the things that lie in the database that run those applications. So it was kind of this read and write paradigm that created a whole new economy around the web. So Web 3.0 allows us to write, but also allows us to own. So this is really exciting because, as we know, with the Web 2.0, kind of these tech giants, centralized services, we have a problem of personal data infringement. We have a problem of ownership of data. We see that these tech giants are making, a lot of their income through our personal data. So Web 3.0 has the capability for allowing us to own our own data. And this is really exciting. So our philosophy at the Web3 Foundation is that we believe in a decentralized internet where people own their data, people own their identity, and therefore their destiny. So this philosophy is what we work towards in the protocols like Polkadot that has been developed, is kind of going to allow for that. Analogous to almost how the early days of the internet, there were protocols being developed for communication of participants on the web. These protocols these blockchain protocols are going to allow for ownership of data, identity, etc. So what exactly is a blockchain then? The simplest way to understand a blockchain is that it's just another database. However, it's much different from the databases that we're used to building on. It has a few interesting properties that makes it unique. So it's secured using cryptography in multiple areas. It's immutable. Updating or deleting values in the blockchain by design is made extremely difficult, sometimes even astronomically difficult that it could be considered impossible. It's decentralized, meaning that a peer-to-peer network of computers and participants control it. It's not like the tech giants like Amazon and Google that have their centralized databases that have administrators that can log into it and then change data if they choose to. Essentially, it's ran by all the participants that have a copy of that blockchain on their computer, and it's public, which is awesome because that means that the data in the blockchain is fully transparent. Obviously, the data is obfuscated using cryptography in different ways. Different blockchains have different approaches to that, but essentially, all blockchain data is public. In a simple way to understand that is that we have a centralized version of a database where there's a single node and all the edges that connect to that node get their information from that one node. If that one node were to go down or were to be hacked, all the edges that connect to that node are therefore under a security vulnerability of some sort. Decentralizing single points is what blockchains do with the data. So decentralizing means that if a certain portion of the network were to go down, you can always rebuild it from the part of the network that's still alive. And so it has this awesome feature which makes it difficult to take down. However, that comes with a bunch of problems that need to be solved as well. So how do the nodes stay synchronized? How do the data on each node make sure that it's the same as the other node? So there's this idea of consensus on the blockchains, and every blockchain kind of has a different way to achieve consensus. But in a simple way, we can think of the blockchain data structure as these chain of blocks that get a new block gets added to the chain and chain to the previous block over time, right? It's like this chronological growth of blocks on the data structure. It's actually not as singly linked chain of blocks. It's a little bit more like this, which is kind of this probabilistic tree structure that grows over time depending on network activity, how the participants behave, and how the blocks are getting added, who's adding the blocks. So it's actually quite complex, but we don't really have to worry about that for the context of this class. We can just imagine, like blocks are where the data lies. Each block has some data in it. It has a block hash, which is its unique identifier, and also it has the hash of the previous block. So then what is a hash? Hashing is a way to convert an input of letters or numbers into a output of encrypted fixed length value. So let's take the example of Bitcoin using the SHA-256 algorithm to create its hashes. It means that it's a 256-bit long alphanumeric output of anything that you put into this hashing function, right? So this is what is being used to create the IDs on the blocks. If you were to take a look at some inputs that goes through a cryptographic hashing function, the output is going to be something that is not representative of the original input. So we don't know what the original input is. We just know that these values represent that input based on the algorithm that is used. So using hashing in using a hashing function to create a block ID, we have block data. We also have the hash of the previous block as a part of that block data. And we put that into a hashing function. You get the hash output, and you use that as the unique ID of a block, right? So this is really important because all the data, the way that it's structured, is baked into the ID of the block. So why is that useful? This is useful because we can create the chaining mechanism using this. So we have block 1 with some hash. There's no previous block. Let's just say block 1 is a genesis block. And then we have block 2, which points to the previous hash. So block 1's hash is baked into the data of block 2, which then gets used to calculate the hash of block 2, and so on and so forth. Now we have this easy way to reference blocks to each other, right? So this has a cool security implication, meaning that if some malicious activity happened on chain and somebody was to try and go change some data in block number 2, they would have to recalculate the hash of block number 2. That's fine. However, that would break the chain that happened to be in between block number 2 and 3. So they would have to go into block 3 and change the previous block hash to the new the hash that they might have generated, and then so on and so forth. This would, in theory, be possible. However, it would be very difficult for that malicious agent to get the rest of the network to adopt this kind of minority version of a of the blockchain that exists on their computer. So this is really cool. We have a really secure way to store data and then reference data storages to each other, right? So at this point, do we have any questions? We've kind of gone over what Web3 is trying to be, what blockchains are, and before we get into Polkadot, I'd like to maybe take some questions if there are any. Checking out the chat. Looks like everybody's doing good. Okay. So just going further, feel free to leave any questions you have in the chat, and then we'll take some once the next section is done. Okay, so we can imagine the evolution of blockchains. It's been over a decade since Bitcoin has been released. And so there are different approaches to, or different kind of paradigms that got built on top of that initial implementation. So we can think of Bitcoin as a generation 1, right? Bitcoin was a decentralized, or is a decentralized store of these Bitcoins that can either be used as a store of value. If you choose, you can transact.
Hi, Emre. Emre, just a quick second. Just to let you know, there are actually a few questions right now with regards to the short Q&A that you were setting. So
cool.
You mind
awesome.
if I can read them out if you want to. So
please.
Yeah, Trevor Phillips is asking, what would happen if 2 blocks within the blockchain would have had the same hash? Is that possible? And if yes, what would happen?
So it can happen. However, the way that tree structure grows, only one of those blocks with the same hash might get included in the longest chain. So the blockchain, as it grows, might have 2 validators or creators of a block that create the same block at the same time. And those 2 versions of the blockchain might start growing independently of each other. However, over time, one is going to end up being longer than the other. And the algorithm that's baked into the code will then choose the one that is the longest. So that is what leads to all these, based on the chain. It could be called the orphan chain, orphan block, or uncle block. So kind of these like offshoots in the tree structure that don't end up being a part of the longest chain.
Okay, yeah, that's cool. Oh yeah, Maybe another question Ayman is asking, is an NFT just a block?
An NFT is a non-fungible token. So we didn't really talk about the token portion of the blockchain. We just kind of talked about the data structure. What's cool about these blockchains is they create incentives, like economic incentives, by having these tokens baked into them, right? Bitcoin has the Bitcoin token, Ethereum has the Ether token, and there is some economics that's baked into how those tokens are incentivize participants to behave. An NFT is a token. However, it's a unique token, meaning that it has no, on the blockchain that exists, that NFT exists on, it has no duplicate. And something like Bitcoin is a fungible token, meaning that there's 21 million of the same exact Bitcoin, right? An NFT will just be a piece of data that lives in a block. So it's not the whole block, but it's just a piece of data that lives on one of the blocks when it got created. So it's a piece of data on the chain rather than being a block itself.
All right. Yeah. Thanks for the insight. That's very interesting. Maybe just one last question from Hossein asking, can we say that the security of a block or the security of a blockchain depends on how long it is?
Yeah, exactly. I think that's what the question was alluding to. Like, instead of block data, replace that with blockchain. A security of a blockchain depends on the consensus mechanism. And simplified, the answer to your question is yes. However, if you take a look at Bitcoin, which is a proof of work network, and proof of work just means that the validators have to expand some amount of energy that the network decides on to prove that they did the amount of work to create a block, right? So they expand computational energy. So the security of the Bitcoin blockchain is equivalent to the amount of computation that happens on the chain, meaning that if you can have majority of the computation that runs on the chain, then you can actually start changing the history of the blockchain. I don't know how many hashes are being generated on Bitcoin right now, but it's a lot. So it's actually just extremely expensive to attack that network. In the case of something like Polkadot, which is a proof of stake network, the security is equal to the amount of value staked on the network. So the validators put down some stake, they lock their tokens into the network, and now the cost to attack that network is based on how much value is locked in the network. If you have majority of the locked value in the network, then in theory you can change history in the network. So the cost of attacking a proof of stake network is defined by that. The cost of attacking a proof of work network is defined by amount of computation.
Yeah, that makes a lot of sense. Thank you. Thank you. I think we'll be able to move on with the presentation. That's okay.
Cool. All right. So 1 second. If we look at the evolution of blockchains, there have been communities developing blockchains for over a decade now. We're starting to see generational evolution of the blockchain. Generation 1 is this Bitcoin proof of work blockchain that does its application is the transfer of these Bitcoins on the chain. And then generation 2 is Ethereum. Ethereum is kind of a general purpose blockchain, meaning that it liked what Bitcoin was doing with the Bitcoin coin, and it wanted to allow people to create their own coins and their own token design and their own application specific tokens. And this is kind of like known as a smart contract platform. Smart contracts are these pieces of code that you can run on the blockchain. So Bitcoin was kind of like simple in its way. Ethereum came along, essentially wrapped Bitcoin around with a virtual machine that allowed you to execute code on it. And then Generation 3 is networks like Polkadot, and we'll talk about what we try to do, but in its essence, it tries to create interoperability of these isolated networks. So Bitcoin, Ethereum, they're their own networks. They don't really communicate with one another. Polkadot and Generation 3 blockchains are trying to create some interoperability of blockchains. And we'll kind of dive into what that means. So yeah, as we say, welcome to Polkadot, introduction to Polkadot. So Polkadot is a layer 0 heterogeneous multi-chain that connects and secures blockchains with pooled security and interoperability. So what this means is Polkadot is a layer that's going to sit, depending on your worldview, at the bottom or at the top of the blockchains that exist, the blockchains that are application specific and isolated. Polkadot wants to kind of be a hub for them to connect to and interoperate. One of the really interesting developments that Polkadot offers to the blockchain realm is that growing your own network from scratch is very difficult. Now that Bitcoin has done it, and and now there are known attack vectors to these blockchains. We know how to attack them. We know how to take them down. They're very vulnerable in their early stages, right? Before Bitcoin had all the security it has now, or before Polkadot had all the locked value it has now, in its early days of the network, it's very susceptible to some well-known attacks. That's where pooled security is going to help out for new ideas. So Polkadot has, a certain amount of locked value, makes it extremely secure. So if you were, if you had like some cool idea to develop a blockchain, all you have to do now is actually just develop on Polkadot. And as soon as you deploy it on Polkadot, it's already as secure as the main chain. So you don't have to build your network from scratch anymore, which is great. It allows for quick prototyping and testing of ideas. You don't have to kind of worry about any, networking level stuff, boilerplate stuff. So it's quite actually awesome. So why Polkadot? So that interoperability that I talked about is really where we believe the Web3 decentralized applications are going to happen. So let me rephrase that. So the Web3 applications that is exciting will probably be using multiple chains. So we need chains to be able to communicate with one another in order for interoperability. So let's say one chain does finances, like decentralized finance. Another chain does something like security through different threshold cryptography. And then another blockchain does social networking. Another blockchain does identity. Now you can actually compose those 4 chains together to create your dApp, to create your product that's going to be used by the general public, right? So right now, a lot of friction that I see in the realm is that we're trying to use the protocols as the products. And what really needs to happen is that these protocols need to be kind of abstracted upon for the real products to come about. So that's what interoperability is going to help out with. The pooled security, kind of as I talked about in the beginning, enables an easy, secure development realm for the new blockchain ideas. And then these heterogeneous chains, so chains that have their own tokenomics, that have their own consensus layers, are going to be able to interoperate together through Polkadot. If you look at the example of Ethereum, Ethereum is, if you release a smart contract on it, it's running on the same virtual machine using the same consensus layer, security, etc. So if there was some smart contract that released an NFT and they're doing an NFT release and there's like massive amount of throughput, into that smart contract, the whole network's throughput is affected by that. And therefore, the cost of running a transaction or the transaction fee will be impacted for all the other smart contracts that live on that network. So with the heterogeneous chain model, this sharding of chains, this separation of concerns makes it so if your chain is doing something, some specific application, and then there's an NFT release on another chain, the throughput of that chain is not going to impact yours. And then one of the most important parts of Polkadot is this idea of on-chain governance. What we did with the DOT token is the design of the token allows you to participate on how the network gets developed. Any type of runtime updates or upgrades to the network is going to go through governance that is on-chain, and DOT token holders can participate in this governance and decide on how the network grows. The architecture of Polkadot is quite complex, but is extremely scalable. There's this idea of the relay chain, which is the main connector chain. And then all the other kind of connected chains would fall under what a parachain is. There's going to be different ways to connect in the future. However, a parachain is just a kind of this default way of thinking about how to connect to the relay chain, a third party layer 1 that lives on top of the relay chain. And then the interoperability is enabled by this cross-consensus messaging protocol that has been developed and is being developed further. There are certain kind of like light versions that are running on production right now. The consensus messaging protocol doesn't care about what type of data is being passed around. It just cares about the structure of the message. You can think about this as similar to how TCP is being used underneath all the HTTP protocol functionalities. So TCP is going to be uniform across the network. XCM is kind of similar. XCMP lives on top of XCM, which is the cross-chain message passing, so parachain to parachain. And then what's being developed is upwards and downwards message passing. So parachain to relay chain to parachain. And there's going to be just messages all over that's going to communicate transaction information, state information, NFT information, identity information, proof of ownership information. So this messaging is going to be kind of the core of the interoperability. All of this is network is kind of running, and it has these different layers of interactivity, these different layers of utility. And the DOT token is kind of the key to participating in that. So currently there is about 1.17 billion DOT tokens. And using the DOT token, you can stake on the nominated proof of stake system, which is a portion of the consensus layer that chooses who the validators of blocks are. And then there's the participating in on-chain governance, as I mentioned right before this. And then there's also participating in parachain auctions and or crowd loans to help parachains win auctions. And we'll kind of dig into that in a little bit more detail. So the DOT token has these three utilities. And then there is this idea of testing ideas on the blockchain. In the Web2 world, you have test networks. You know, you develop a new piece of functionality in your web app and you deploy it to the test network. You make sure it works. QA does its thing. They click the button does what it does. It's the right color, whatever. And then it's ready to go to production. Blockchains, it's a little bit more difficult because the blockchain has this network in which there are real participants using real world value, these tokens that have real dollar value, right? So testing ideas or some types of updates to increasing the amount of validators there are, or the type of cryptography that's used, or whatever, is going to have some implications that are not easily testable on a test network, though we have test networks. That's where Kusama comes in, a real value-bearing canary network where ideas can be tested in an environment that is sped up in certain ways, and has real world value before it goes on to Polkadot. So Kusama is actually becoming its own fully pledged blockchain environment where certain products are choosing to stay only on Kusama and not even go to Polkadot. So so it's not a test network. It's used for testing, but it's like this real network. Essentially, it's very similar to Polkadot, except certain different properties that allow faster a sped up cycle in the realm of Kusama. So what does it mean to build on Polkadot? We have this layer 0 chain with interconnected chains. If you want to be your own parachain, or if you want to run decentralized applications on Polkadot, what does that mean? That means that we have to understand what Polkadot is built on. Polkadot is built using Rust. Rust is a low-level programming language that has some really cool benefits to low-level programming, such as ability, some tooling for testing, for error handling, for networking, and kind of a great development environment. The team that developed Polkadot early on realized that, okay, so before we had Bitcoin, Ethereum forked Bitcoin and then developed on top of it. And then, there's other blockchains that are forking existing blockchain code bases to kind of like change the parameters or the values that to make it work for their own application specific approach. Why not make a framework to build blockchains and then build Polkadot using that framework? And that's exactly what Substrate is. So Substrate is a framework, the first kind of generally adopted, well-maintained blockchain development framework. You can kind of think of how React was a framework for building UI. It was built on JavaScript. So Substrate is a framework for building blockchains built on Rust. So Substrate understood that there are these modules that need to be created that have, so blockchains have things like wallets and accounts and balances and consensus mechanisms and types of cryptography. Why not just create modules for all these that we can use as building blocks, kind of like Legos, to build blockchains? So Substrate created frame palettes, and frame palettes are these modularized versions of what comprise a blockchain. So when you develop your runtime, you can just choose a collection of these palettes to work together to develop your own application-specific blockchain. It has some powerful implications, that modularity that gives kind of like this pluggable component development framework where if something happens, so blockchains are still figuring themselves out, so they need to be flexible. If a certain part of your blockchain is no longer working, that needs to be modular so that you can plug it out and plug in the portion that gets newly developed or wants to get tested. Or there's a new, better consensus mechanism out there. Let's not rewrite the whole blockchain. Let's just plug out the part. So it kind of has this seamless integration and making sure that the power of that upgradability is going through on-chain governance. Substrate is making sure that if you use the governance palettes, upgrades to these palettes or the runtime needs to be voted on by the token holders. So these are really powerful paradigms in how blockchains get maintained and stay healthy. Substrate is extremely quick, so you can have a lot of transaction throughput due to some of the consensus decisions that were made on the, for example, Polkadot if you look at Bitcoin, it has this probabilistic finality mechanism, meaning that once a block gets added to the chain, the deeper the block goes into the chain, the more and more difficult it gets to change that block. However, early on, when the block gets added, it's vulnerable to certain types of attacks. Polkadot created a hybrid consensus mechanism that takes the benefits of this kind of longest chain probabilistic finality, but on top of it builds a deterministic layer that made some assumptions about the network, saying that, let's say 2/3 of the network agrees upon the blocks that are going to get added, we can actually speed up the process of adding blocks by batching a bunch of blocks together rather than adding one block at a time. So this hybrid consensus allows for much quicker finality on the chain, but has some cool security implications, meaning that if the deterministic layer has some sort of problems, it will always fall back on that probabilistic layer. Substrate is upgradable, avoiding messy political forks. So forks divide, so forks can be good and bad, right? So we have forks are when, let's say, somebody wants to build a new blockchain and they fork Bitcoin, that's a fork. Or they want to include a runtime upgrade, that's a fork, meaning that you're taking the code base, creating a copy of it, and then developing it on the new copy and leaving the old copy as is, creating these divergences. And so in those divergences, you can have a lot of political problems, community problems. We've seen, for example, Bitcoin and Bitcoin Cash had this problem of how to scale the network. And then the big blockers forked the network and then built Bitcoin Cash. And then that didn't pan out super well for them. But, just want to interject there, my own idea is that this is incredible. Just the fact that you can have a financial system and you disagree with it, and then you just make your own copy and then develop it further. And if your idea seems to be correct, the market will probably gravitate towards that. I think that's super cool. However, it's messy. So what Substrate allows us to do, what Polkadot allows us to do, is to do forkless upgrades. What Substrate code can boil down to is WASM, WebAssembly code, which is just a runtime that is readable by computer machines. So you take your runtime, you boil it down to WASM, and you include it in a block. And now you're going to just have, once that block gets added to the network, the runtime is going to have the changes that were in that WASM. Great. So now we've gotten rid of the idea of messy forks. People can still fork the code base and then develop their own version of Polkadot if they choose. But the updates that happen on Polkadot through the developers that are working on Polkadot and the token holders no longer need to fork the code base. For example, upgrades to Ethereum to get to Ethereum 2.0 is a collection of forks, right? So let's get rid of that. Let's make it a little bit simpler and easier and quicker. Blockchains need to be able to adjust quickly, and this allows for exactly that. So Substrate features a rich ecosystem, ability to build blockchains using some of the frameworks that I talked about, like frame palettes, build on client apps. So we have Polkadot JS UI that's really useful for development, but there's also kind of light clients and wallets, and then ability to do end-to-end deployments, and then monitoring, some sort of, there's a collection of on-chain kind of, what are they called? Block explorers, chain explorers that exist in the environment. Okay, so we talked about these ideas. Then what does it mean to become a parachain? How do parachains get onboarded to the network? Parachains have to win parachain auctions. So auctions are the network and the token holders will vote on how many parachain slots to open up and how often. That goes through on-chain governance, gets included in a runtime upgrade, and now there's going to be a parachain slot that's going to be available for parachain teams to bid on. And these auctions are using a candle auction mechanism. Candle auctions are this old form of auctioning that you don't know when the candle goes out, but when it goes out, the auction is over. And this incentivizes auctioneers or people that are participating in the auction to not wait till the last minute, kind of like an eBay style auction. What happens is that the auction starts, and between the start and the end time of the auction, parachains will bid for that slot. And then when the auction is over, the randomness function will be used to pick a time in the past, and that whatever auction, whatever bid was in that block in time will be the winner of that parachain slot. Meaning that this incentivizes parachains to put their bid in as soon as possible and as often as possible. So most of the time, you'll see parachains putting a bid for the entire duration of the auction, hoping that they are the one that the randomness function lands on in retrospect. So how do you fund? How do you it takes a lot of money to win these slots. So there's a crowd loan functionality. If you have a good backing through your community, you can ask for your community to participate in your crowd loan by giving DOT to your crowd loan bid or your auction bids. So the community can fund the bids now. And this is really cool. This is kind of a if you looked at kind of like the ICO craze of 2017, right? Like you would have this wallet address. They'd be like, send me your Bitcoin, send me your Ethereum. And you would hope that like they would use that for what they promised in releasing this new idea. This crowd loan functionality is great because you can participate in the creation of new blockchains. However, your DOT is locked on the relay chain. It's not owned by the parachain team. So once the parachain slot lease is over, it does have an ending time, that parachain slot that need to get auctioned off. The crowd loan that you participated in, the amount will just get returned to you. So essentially, crowd loan participation is a way to lock up your token, as a way to signal your support for new blockchains, not a way for you to give your tokens directly to them. So it's kind of a better way to participate in creation of blockchains. And a common misconception is that what if a blockchain doesn't win an auction? What happens to my crowd loan money? Well, that crowd loan money will get deposited back into your wallet if they do not win. And also, a project does not have to be a parachain to be running on Polkadot. They can be a parathread. There's going to be certain slots that will actually be running multiple projects on a single parachain slot. Cool. So the ecosystem is awesome in the way that there's 150 chains being currently developed, bunch of APIs, 18 plus production networks launched on Polkadot and Kusama, over 50 billion in market cap combined locked in these proof of stake networks. All of these are projects that are being developed on Substrate: DeFi, NFT gaming, smart contracts, identity, privacy, bridging, IoT, etc., etc. Now these are actually open for composability for you to build your decentralized applications on. A bunch of API tools and services. And the Web3 Foundation, as well as Parity, working with a bunch of organizations around the world, are trying to fund a lot of good ideas. So there's the Substrate Builders program, that if you want to build your own chain, your own type of infrastructure update, your own type of application like a wallet, you can actually get funding for it if you have your MVP. The Web3 Foundation, we have grants. So if you have an idea, there's a transparent way to get grants, a funding for it. So this is all on GitHub. If you go to GitHub/W3F/grants program, you can see how to apply for getting some money. And then there's like on-chain funding mechanisms such as the treasury. So there's hundreds of millions of dollars worth of tokens waiting to be given to ideas in the ecosystem. And then there's accelerators, incubators, which are kind of like more formal approaches to funding and developing ideas. And with that, thank you. This is kind of the Polkadot and Polkadot ecosystem, blockchain, Web3. I hope this was useful, and we'll just take some questions now.
All right. Yeah, Emre, thank you so much for the insights. I think that was a very interesting presentation that you were able to give us. Maybe if we look at the questions, oh yeah, the first question from Nikhil asking about verifying transactions within the blockchain. So if in proof of stake, the validators are decided by the number of coins or tokens they stake, so don't you think that it alters the decentralized property in general?
Yeah, so this is a huge problem in the proof of stake consensus portion that chooses validators. And that's why there's a lot of kind of flavors of proof of stake trying to solve this problem. What nominated proof of stake does is it uses certain algorithms to make it as equitable and even as possible to give priority to the lower staked agents. So you can be two types of participant in nominated proof of stake. You can be a nominator and you can be a validator. And what nominators do is they elect validators on Polkadot and on Kusama. And then certain algorithms get used to distribute all the staked value in a given time to equally distribute among the participants of the staking, I guess like the active staking set. And then there's like different approaches to kind of distributing that value equally. But yeah, that's a really good question. Essentially, it's a big problem that needs to be thought of and solved in a thoughtful way.
Yeah, yeah, thank you so much. I think it's just good that you sort of reveal that there is also sort of downsides to blockchain at the moment if we look at verifying transactions. Maybe the second question from Korea, is it possible to open Bitcoin nodes over Polkadot?
Yeah, so there's a few bridging solutions that are working on trying to bridge Bitcoin to Polkadot. Your question, it's not exactly running a Bitcoin node on Polkadot, but it's actually being able to use your Bitcoins on these applications built on Substrate on Polkadot. So there's different ways to kind of approach that. Like I think Interlay is trying to do this. I think won a parachain slot on Polkadot. If you want to look at how they're solving that problem. So essentially bridging and creating parachains that have, so for example, Moonbeam or Akala allows you to run Solidity smart contracts on Polkadot because they have a EVM runtime palette on their Substrate implementation. So there's different ways to bring these external tokens and networks into the Polkadot ecosystem. And there's like different approaches that are being worked on.
Okay, yeah, very cool, very cool. Thanks for that. Maybe just a third question from Luke Phillips. If something, for example, a financial report is based on a data point found in a blockchain and the hash of the block is rewritten, will the report then be invalidated?
if something like a financial report is based on a data point found in the blockchain and the hash of the block is rewritten, will the report then be validated? Yes.
Okay. Okay. All right. That was Okay. Maybe one more about the XCMP. It's kind of difficult to abstract when you come from an OSI model. Do you have an opinion on that, or can you elaborate?
I guess I don't know what an OSI model is. Let's look it up. All right, so OSI model, 7 layers, physical data link, network, transport, session, presentation, application. Okay, client side, server side, right, okay. So like an OSI model, what they mean by that is you have your database, and then you have your client side, and then there's like these layers in between that allows the interaction, as far as I understand. So with XCMP, it's kind of difficult to abstract when you come from an OSI model. I think instead of thinking about XCMP as a server-client interaction, think about XCMP as more of a protocol similar to TCP and IP. So IP is, the location of a server or a node on the web, and then TCP uses that IP to pass packets of data little by little, and then those packets are, received by the recipient and then packaged together to see what is being given to them. That is just in its own, like maybe 2 layers, right? Like you have the IP layer that has the location services, and then you have the TCP, which is the transfer control layer that defines how packets get chopped up and then concatenated back again. With the OSI model, I think it's just, if you're trying to fit XCMP into like an OSI model, it's a little bit like too complex. Think simpler. So XCMP is going to allow messages to just get passed through the network between parachains, and then XCM, the cross consensus messaging format, is going to define how those messages are kind of structured.
Okay. Yeah. Thanks a lot. I think that was a good insight. I was just wondering because you were planning a short demo with us. I was wondering if whether you would like to do that or just continue with the Q&A for now. It's up to you.
Yeah, I think so. There's a game that I like to play where we build a blockchain to kind of get a better idea of like how the chaining and the hashing works. But I think maybe our time is a little bit better used by just answering some more questions. There's some really good questions out there.
Okay. Yeah. All right. Thanks for that. Okay. Just one question from Stofa. What if there's a typo in a block already on the blockchain? How do you fix this?
What if there's a typo? So this is something. This is an interesting question because essentially the consensus mechanism should not include blocks with typos in it. So I think the typo example is a little bit of a weird one because everything in the block is usually hashes, and if there's let's just reword that question to say, if there is something wrong in the block, right? If there's some sort of like wrong value in the block, how do you change that? Well, the validators that are adding the block to the blockchain should see that and not add that block to the blockchain if something is somehow wrong. And there, in the proof of stake model, there are ways to actually punish this. So if there are people trying to add blocks with, like, let's say malicious data, if they're saying instead of sending 10 values of something, I only sent 1. So they're trying to keep 9 values in their wallet somehow, but also have the other end receive 10. They're trying to kind of game the system. there are mechanisms called slashing in the proof of stake realm that allow that type of like malicious activity to be disincentivized. So the way that blocks get added to the blockchain is a very complex process, and the blocks that end up getting finalized on chain have been validated by the majority of the network. So in a more philosophical approach, if in theory your typo gets added to the network and all the validators agree on that typo, actually now that typo becomes truth. And it's no longer actually considered a typo. It's actually considered something that is real.
Wow, well, that's actually very calming that like this whole process of validation of a block, so that there's no worry about well, human error or failure issues. Maybe a question from Ingo. At what point do you consider a blockchain sufficiently decentralized? I think this is referring to the length of the blockchain. Yeah.
Yeah. No. So why not the length of the blockchain? Because you can have your code adding like 10 blocks a millisecond, and then you might have the longest chain within a day or whatever, but it might not be ran by more than 2 validators. So it's not the length, but the amount of unique participants is a good indicator. The number of like validator nodes that are running, how distributed are they across the globe? So this is a really good question, because you also don't know if one company runs a majority of the nodes. Like there's no way unless so Polkadot has in Substrate there is a way to identify your node on chain. So that could be like looking at uniquely identified participants on chain that are also validators. But in something like Bitcoin, we don't know who's running the miners. Like one person could be funding a mining operation in China, and one same person could be funding an operation in the US and Russia. So are those nodes sufficiently decentralized? In a way, yes, because there's 30 there, 30 there, 30 there. If the attack was to take down, let's say like China blocked off the 30, you still have some nodes, but they're run by the same person, so they're centralized on a different layer. So actually the way to calculate decentralization is something I feel is really going to be important, especially as regulation and better ways to understand how sufficiently decentralized our networks. And maybe if there's people out there that know good ways to measure network decentralization, hit me up. I'd love to like learn more about that.
Okay, I think unfortunately we've oh no, sorry, never mind. Maybe just one question from me personally. Is there a specific reason with regards to parachain auctions? Is there a specific reason behind why there's an interval of 2 weeks between each auction?
Yeah, so the first batch, there wasn't a interval, but now there is. An auction runs for a week. A parachain gets wins the bid for that slot, and then there's a week off, and then another parachain gets added. So I'm going to be fully honest with you. I don't really know the answer to this, and I probably should. But one hunch I have is that it makes sense to make sure that we're onboarding in a healthy speed. So making sure that like we're not just like adding parachains. Another one is onboarding periods. So once a parachain wins the auction, I think don't quote me on this, but does it take a week for it to get onboarded? And then so that's maybe why there's that week buffer. But I'll get the answer for you and message you personally. I should probably know this, but off the top of my head, I don't.
No problem at all. But that's very helpful insight. Maybe just one final question before we wrap it up.
Sure.
How does the fact that you get crowd loans back after each auction affect the overall voting process?
Overall voting process?
Yeah, in terms of
voting process. Wait, so what do you mean by voting process?
I personally would have assumed that voters, knowing that they will get their crowd loans back, will maybe change their voting behavior in a way that there's maybe a different or much more diversified distribution in votes.
Yeah. Super good question. And the reason why I had to kind of clarify the voting part is, I guess you are voting with your tokens on which parachain should win, or increase probability of winning. I didn't think of, I was thinking voting more like on-chain governance voting. So yeah, this is a interesting approach to token design, right? So token design, there's a lot of implications that come with how many tokens you mint, what your inflation rate is. So I think it's like 7% on Polkadot right now. And then, like the scarcity of tokens through either being locked up in, if you lock up tokens in the crowd loan mechanism, which is kind of like 2 years on Polkadot, the maximum parachain slot lease period, and then getting locked up in staking, which these tokens are getting locked, meaning that the available liquidity of tokens are being impacted directly by that. So how the people will behave based on this information is a great question, but I don't know if there's a single answer to it. So it could mean that people will be more excited to lock up more of their tokens. So if it was a 2017 ICO model, people might be more hesitant to give a bunch of Bitcoins or Ethereums to some idea that might end up running away with their cash. Or in the crowd loan mechanisms, they might feel a little bit more secure to participate in more crowd loans. And actually, in theory, it could incentivize more participation in the crowd loans. So that's one thing that comes to mind.
All right. Yeah. Thank you so much for the insights. I think that was a good way to wrap this all up. Thank you to everyone who attended this session. Thank you so much for providing us with the insights, Emre. And I would just like to quickly mention that this is a very special occasion, as this is the first partnership between ETH Zurich, Google LSE, as well as many other Google DSC leads around the globe, especially the US as well as Canada. So you can look forward to seeing more exciting events as a form of partnership. And also feel free to check out the other chapters around Google DSC, so ETH, LSE, and so on. Yeah, do you have anything to add?
Yeah, thanks a lot, Emre, for your presentation today. And yeah, at the GDSC Zurich next week, we have an event on competitive programming and one from a speaker from NASA. So if you guys are interested in that, check out our website. But other than that, have a nice evening or day wherever you are in the world. And thanks for joining us.
Awesome. Thanks, everyone.
All right.
Google Developer Student Clubs train hundreds of thousands of university student developers globally while having fun getting to know other students at their school. Google selects students with strong leadership skills from across the globe once a year to start a club on their campus. These leads believe knowledge is power and that technology can do extraordinary things for the world. They take on the responsibility to help students learn and empower each other to solve real problems around them. Students can participate in the annual Solution Challenge by Google developers to solve for one of the United Nations Sustainable Development Goals. Join us in building a global community for students in technology.